Welcome to class 11th and class 12th math classes and JEE preparation. Let's learn relations and functions, unit 2. Okay, this is from the NCERT book. This is chapter 2. If you want to practice the questions, this is chapter 2 of NCERT book. This is mainly meant for all engineering entrance exams and class 11th and class 12th. Okay, so if you know, much of the mathematics is about finding patterns and relations between quantities, right? So if you follow any of my Olympiad classes online, okay, many times I have told that mathematics is all about finding the relation, okay, and pattern, right? So let's learn relations and functions, okay, in this chapter, in this video. Okay, what we are going to cover is Cartesian product of sets. Okay, you have already hope you have already gone through the past video, that is sets. Okay, now we are going to learn the Cartesian product. We have already got introduction to Cartesian product in the previous chapter. Okay, we'll learn it more, and then we'll derive what is relation from that. Okay, and then what is function. Okay, then we will also, I'll just show you all the NCERT chapter 2 problems. Okay, solutions of it. Most of it I will not explain it, but all the tough questions and good questions I'll explain. Okay, but you can do it yourself and find the solution. And most important thing is all the tough questions, many of the tough questions I have chosen from JEE on relations and functions. I will cover them here, at least 5 to 7 tough questions I'll cover. In my uh, next videos, I will cover more and more problems from for engineering entrance and JEE on these sets, relations, and functions. Okay, this is just introduction, and I have covered very good questions from JEE on relations and functions in the end, almost 7, 8 questions. Okay, let's go. Okay, yeah. What is the Cartesian product of sets? We already saw what is Cartesian product. If there is a, let's say, set A is defined as red and blue color, and set B is defined as shirt and pant. Okay, then Cartesian product of A and B is a ordered pair of red shirt, red pant, blue pant. Okay, if I write it in the uh, rooster method, okay, it will be A cross B equal to A into B, or A cross B equal to ordered pair A comma B, such that A belongs to A, B belongs to B. Okay, this is the simple set builder method. Okay, now if number of elements in A are P, number of elements in B are Q, then number of elements in A cross B will be P times Q. Okay, if any of the set is null set, then number of elements in A cross B will be 0. Okay, now two ordered pairs are equal if and only if corresponding first elements are equal and the second elements also equal. Okay, if I say ordered pair A comma B is equal to C comma D, then A is equal to C and B is equal to D. Okay, note down this. Okay. If I extend my Cartesian product to 3 sets, then A cross A is equal to ABC, such that A comma B comma C belongs to A. Okay, so here A comma B comma C is called ordered triplet. Okay, not pair, right? It's triplet. If R is a set of real numbers, then R cross R is a x comma y, right? X comma y and x comma y belongs to R. This is the coordinates in the two-dimensional space. R cross R is all the coordinates in the two-dimensional space. Okay, if R is a set of real numbers and R cross R cross R, R into R is a all the coordinates in three-dimensional space. Okay, if in graphs, if you convert, this is what it is. Okay, so this is the basics about the Cartesian product. Let's do some exercise from NCERT book chapter 2. Okay, exercise 2.1. First, pause this video and solve it yourself, all these problems. Okay, all these problems you can solve it yourself, and then check my solution set if you're correct or wrong. Okay, these are all very straightforward questions and basics about Cartesian product. Okay, so if this x, I mean two ordered pairs are equal, I told you both first element should be same and the second element should be same, correct? So it is very simple to solve. Okay, x plus 3 plus 1 equal to 5 by 3, so you'll get x value, and then second one, y minus 2 by 3 equal to 1 by 3, so you get the second value. Okay, y value from that. Okay, x comma y is 2 comma 1. Okay, then if A has three elements and set B is 3 comma 4 comma 5, then find the number of elements in A cross B. Okay, for A cross B, you don't need to know what are the elements in the set. You just need to know number of elements. Okay, so this is the answer. Okay, G cross H and H cross G. The ordered pairs will be exactly reverse. Okay, if 7 comma 5 belongs to G cross H, then 5 comma 7 belongs to H cross G. Okay, next, true or false statements. Okay, is it correct? It is false because P cross Q has more elements actually. Okay, it should have 4, right? Number of elements in PR2, number of elements in QR2. So 2 by 2, you should get 4 elements actually in P cross Q. Okay, so that's false. Okay, so this is another one which is true. Okay, these are all straightforward. Okay, so I'm not going to take much time on these. Okay, this is 5. Okay, null set. Okay, next. Yeah, this is also fairly simple. You just try to write all possible combinations of -1, comma 1 in ordered triplets. Okay, so this sixth question, if you see, okay, always in an ordered pair, the first element belongs to set A, correct? And the second one belongs to set B. Okay, so if you see, what are the set A possibilities? A comma B, right? And set B is X comma Y. Okay, next. Yeah, this is also fairly simple. Okay, just write the Cartesian products correctly, then you will know if it is correct or not. Okay, next. Yeah, how many subsets of A cross B? First, you write A cross B. A cross B will have 2 into 2, right? 2 elements in each set. So 2 into 2, 4 elements are there in A cross B. So number of elements in A cross B are 4. Okay. Number of subsets of A cross B is 2 to the power of 4. We know already subsets when we learned in sets. Subsets, if n number of elements are in set A, then 2 to the power of n is the number of subsets possible. Okay. So, and these are all the subsets. Okay. Next. Yeah, this is also fairly simple. You can write it yourself. Okay, first you solve it yourself and then cross-check the answers. Now, let's go to relations now. Relation R is from a non-empty set A to a non-empty set B. Okay, and this is a subset of the Cartesian product of A cross B. In A cross B, you have every element in A is paired with every element in B, correct? In a ordered pair. Okay, but relation is defined by a rule. Okay, the rule says maybe the element in B is ordered pair B. If A comma B is the ordered pair, B is always greater than A. Some relation, some condition is given. Okay, and based on the definition of the relation, you write the Cartesian products. Okay, the ordered pairs basically. Okay, so this is definitely very clearly from the definition we can see it is a subset of Cartesian product of A cross B relation is. Okay, the subset is derived by describing a relationship between the first element and the second element of the ordered pair in A cross B. Okay. So let's say if A cross B is this one and A is 1, 2, 3, B is 4, 5, 6. Okay. Then relation can be represented in any of the three forms. Okay, rooster form, we can write it like this. Suppose in a rooster form, these are the ordered pairs possible. And set builder form, I will tell that it is x comma y such that y is greater than 2x. Y is greater than 2x. Okay, so cross check with these values. Y, this is y, right? Y is greater than 2x. Y is greater than 2x, greater than 2x. Okay. So this is how you can write. You also get actually uh, 3 comma 6 you don't get because y is greater than or greater than or equal to. Okay. So these are the possibilities. Okay. So hope you understand the relation definition. Relation is basically subset of a Cartesian product defined by a condition or relation. Okay. The graphical form is you will represent like this. Okay. This is your set A, this is your set B, and relation is defined as arrows. Okay. In a Cartesian product, every element will be mapped to the other element. Okay. So you will have 3 from 1, 3 from 2, 3 from 3 going to 4, 5, 6. Okay. So, but here it is relation is only to 1 comma 4. If you see, I am okay with the arrow I represent it. Okay. Okay. And the relations in a relation, it is possible that you can leave some of the elements are not part of the relation. Okay, that is possible because they are not meeting the condition. Okay, and those elements which are not part can be from the set A or set B or from the, we call it the first element of the ordered pair. We call in a relation domain. Okay, so domain here is 1 comma 2. Okay, only 1 comma 2 are participating, right? So 1 comma 2 is my domain. Okay, then range is 4 comma 4 5 6. Okay, 4 5 6. One is not participating in the range. Okay, so this is 4 5 6. Now you call this complete one as, okay, codomain. Codomain is 1 comma 4 comma 5 comma 6. Okay, and you also, yeah, you also call this relation represented by R. Okay, so you can say that 1 R 4. Okay, 1 is related to 4, 1 R 5, 1 is related to 5, like that you can say. Okay, 4 5 6 are the images of 1. If you see here, 4 5 6. Okay, so if 1 is the element in first set. Okay, then 4 5 6 are 6 are elements, images of 1. Okay, similarly 5 and 6 are images of 2. Okay, and very clearly we can say range is always subset or equal to codomain. Okay, range is always subset or equal to codomain. So these are the important things for the to remember for relations. Okay, the total number of relations that can be defined from set A to set B, okay, is the number of possible subsets of A cross B. Okay, if number of elements in A is P, number of elements in B is Q, then number of elements in Cartesian product is PQ, right? P times Q. Then total number of relations which are possible from A to B are 2 to the power of PQ. 2 to the power of PQ. Remember this. Okay. Now again, we'll go through this NCERT book, chapter 2, exercise 2.2. I'm not going to explain any of this. These are all straightforward questions. You can solve it, pause the video, solve it, then cross-check the answer. Okay. Okay, all are fairly simple. Okay, so very basics. Don't miss it. You have to solve it yourself just to get accustomed to the relations and functions, because as we go, we are going to solve tougher problems. Okay. Okay, this relation you have to represent in the set builder and rooster method. So set builder method is here, x comma y such that y is equal to x minus 2. Okay, 5 is related to 3, 6 is 4, 7 is 5. Okay, correct. Always 2 less than. Second element is 2 less than the first element. Correct. So y equal to x minus 2, and x range is x is between 5 to 7. Domain is 5 to 7. Okay, 5, 6, 7. And in set builder method, you will directly represent as ordered pairs like this. Sorry, in rooster method. Domain is 5, 6, 7. Range is 3, 4, 5. Okay. Next. Yeah, this is also fairly simple. Okay. So here it is given in set builder method. You just write it in the, okay. Domain of R is this one. Range of R is this one. Okay. Write it in the rooster form here. Okay. Now let's learn about the functions. Okay. Now first we learned is Cartesian product, then we learned relations. Now let's go to functions. So function is again a subset of relation. Okay. And here a relation f from set A to set B is said to be a function if every element of set A has one and only one image in set B. Okay, which means you cannot have two images of element in set A. Okay, first set you cannot have one element in, if you take any element in set A, you cannot have two images of that one in set B. Okay, that's the definition of a function. That means it has a unique image. Okay, every element in first set has unique image. That's the only thing. Okay, then it's called a function. Function is a relation from non-empty set A to non-empty set B such that the domain of F is A and no two distinct order pairs in F have same first element. Okay, first element cannot be repeated in the ordered pairs. Okay, that's the only condition. So let's see. First one, I'm drawing a graphical method. So first one is definitely very clearly it is a function because every element has unique image. Okay, one is 4, 2 is 5, 3 is 6, unique image. So no problem. Correct. So this is a function definitely, and this is also called one-to-one function. Okay. Second one, not a function for two reasons. One is 3 don't have any image. 3 don't have any image. That is one. It's not a. You can tell it's not a function. Also, one has two images. One has 4 and 6. Two images are there, so it is not a function. Okay. Now here 3 has an image, no problem, but one still have two images. Okay. So this is also not a function. So now you know the definition of this one. Okay. So clearly we can see function is also a subset of relation. Relation is a subset of Cartesian product. Okay. A function which has either R or one of its subset. Okay. R means real numbers or positive real number or negative real number or okay non non-zero real number or any of that subset you take. Okay. If the function has R real numbers or its subset as its range, then it is called a real valued function. Okay. If its domain is also R, also a real number or subset of real numbers, then it is called a real function. Okay. If domain and range belongs to real numbers, it's called a real function. If only range belongs to real number, then it's called a real valued function. Note it. Okay. Okay. Identifying functions using graph. Okay. Now we know that how to identify a function. Function should not have two images for a single element in set A. Okay. And every element should have a image in set B. Correct. These are the two things. But let's say if a graph is given like this. Now how do you identify if it is a function or not? Okay. Very simple method is you draw a vertical line. Okay. Wherever you have a doubt, it has two elements. You draw a vertical line. Okay. This is a sine wave. You draw vertical line anywhere, you will get only one cut. Correct? Only one place it will have intersection. Okay, then it's a function. Okay, this is a very easy way of finding from the graph if given graph is a function or not. Okay, so this is a function. Now this one, is it a function or not? Very clearly, if I draw a vertical line here, correct, vertical line if I am drawing, then it is intersecting at two places. Okay, so this x value has two y values. Okay, so function is not defined at this place. Correct, function is not defined at this place. So this graph, whatever graph is given, whatever graph is here, okay, this is a ellipse. This don't have a, this is not a function exactly. Okay, because it has at a given point it has two images. Okay, this is also definitely parabola. It's not a, if you draw a vertical line here, if you draw a vertical line here, you may get one value, but at this point it has two values. So it's not a function because at this point for a given x value, you have two y values, right? So the function is not defined here. Okay, more. Yeah, this is a 1 by x basically. Okay, you draw a vertical line. This is a, okay. If you see this curve is not defined at x equal to 0, x equal to 0, okay, this function is only 1 by x only for any number other than 0. X is not equal to 0. So at 0, you don't worry because function itself is not defined at x equal to 0. Correct? So at other parts, it has only unique. If you draw a vertical line anywhere, you have only one value. So it's a function. Okay. And this one is a absolute function. Okay. F of x equal to absolute x. Okay. This is also definitely you draw a vertical line, you will get single values at single intersection. So this is also a function. Okay. Now we can do some operations on functions. Okay. What are the kind of operations which we can do? Okay, addition of two real functions we can do if function is defined from x to r and g is defined from x to r. They have any two real functions, then x is a subset of r. Okay, where is x is a subset of r? We can define as f plus g as x to r by f plus g of x equal to f of x plus g of x. Okay, so plus operation on functions is defined like this. Okay, f plus g of x is equal to f of x plus g of x. Okay, subtraction also same way, f minus g of x equal to f of x minus g of x. Okay, multiplication also possible. Okay, by a scalar, alpha is a scalar here, so alpha f of x is equal to alpha f of x. Okay, multiplication of two real functions also possible, fg of x equal to f of x into g of x. Okay, similarly, uh, quotient or division also possible, f by g of x equal to f of x by divided by g of x. Okay, provided condition is g of x is not equal to 0. Because g of x is 0, then uh, it is not defined. So this is where it is helpful for you to find the domain of the function. Okay, now function has either r or one of its subset, as its range is called a real valued function. Okay, we already saw this one. If domain is also real, then it's called a real function. Okay, so this is exercise 2.3 of NCERT book chapter 2. I'll not go through it. Fairly simple questions, so you can first solve it and then cross check the answer. Okay. Okay, so here domain is 2, 5, 8, 11, 14, and 7. Range is 1. So this is a constant function. Every element in set A has same image in set B. This is called a constant function. Okay. Okay, so you can easily find out domain and range from this one. Okay, this is not a function because 1 is repeated. Okay, first element cannot be repeated, cannot be same. Okay, so 1 is there because for f of 1, we don't know it is 3 or 5. What is correct? You cannot say both 3 and 5, right? So it is not a function. Okay, yeah, you can check how to find a domain of function. Uh, okay, the domain is you can give any value to x, right? From minus infinity to infinity, any value you can give. Okay, so this is basically set of real numbers. Okay, but the range is always negative you will get here. Okay, whatever value you give to the x here, okay, you get a positive value out and then minus apply. So this is only minus infinity to 0 inclusive. Okay, because if x is 0, you will get 0 value. So inclusive. So the range is minus infinity to 0. Okay, 9 minus x square. This is interesting. Okay, and in the square root you cannot have a negative number. So 9 minus x square should be greater than 0, which means x square should be less than 9. Correct? X square should be less than 9. Okay, so that means the domain of x should be minus 3 to 3 inclusive. Okay, because square root of 0 is 0. That is also good. So, but x cannot be anything more than uh, I mean less than minus 3 or more than 3. Okay, the domain is from minus 3 to 3. Okay, and the uh, range of f of x is it can go 0 maximum, right? So then you will get 3. If it goes to 9, then you will get x square is 9, then you will get 0. So 0 to 3 is the range. Okay, so it's fairly simple. You can do it yourself. Okay, this is a temperature function. Okay, Fahrenheit to centigrade. Okay, defined like this. You can solve it yourself very easily. Okay, 2 minus 3x. What is the range? Okay, x is greater than or equal greater than 0. Okay, x is greater than 0. So starts from 1. F of for x equal to 0, it is 2, and take some big number. Okay, some 100. Then you know that it is minus 298. And if you take more bigger number, it will be more negative value, right? You will get. So the range of f of x is minus infinity to 2. Okay. And the 2 is not inclusive because here it is greater than only, not equal to. So each one you have to do it like that. Okay, you have to apply your math skills and then find out the ranges and domains. Okay, let's do the miscellaneous exercise from the NCERT book, chapter 2. A real function is defined as f of x equal to x square. Okay, x is between 0 to 3 inclusive, and f of x equal to 3x, where x is between 3 and 10 inclusive. Okay, and g of x is also defined as x square, where x is between 0 and 2, and g of x is defined as 3x when x is between 2 and 10, all inclusive. Show that f of x is a function and g of x is not a function. Okay, so if you see it, the definitions are same exactly. Only thing is the domain of x is different. Right? X domain is different. Okay. So first what we should do is, if you take f of x, okay, f of x has two definitions only when when x is equal to 3. Okay. Remaining all, it has a unique definition. So there is no problem. F of x will have a unique value, unique image for every pre-image for any value other than 3. Okay, from 0 to 10. Only at 3 we have to find out. Okay, so let's find out what is the value at f of 3. Okay, with the two definitions, because 3 is inclusive here, 3 is inclusive here also. Okay, so f of x is f of 3 equal to 3 square, which is 9. F of 3 equal to 3x, which is also 9. So which means f of 3 has a unique value. Correct. So this is a function. Okay, f is a function. Okay, now let's check the same thing for g of x. This is also same, only at 2 we have two definitions. So let's check at 2. G of 2 equal to 2 square, which is 4. G of 2 equal to 3x, right? So 3 times 2, which is 6. So here G of 2 has two values. Okay, right? The images of 2 are 4 and 6. There are two values. So that means this is again is the definition of a function. So G of x is not a function. Okay. So yeah. Next. If f of x equal to x square, find f of 1 dot 1 minus f of 1 by 1 dot 1 minus 1. Okay, yeah, simple substitution. Yeah, only thing is once you get this one, 1 dot 1 square minus 1 square, you can divide this as a square minus b square, which is a plus b into a minus b. So you will get 1.1 plus 1 is the answer, which is 2.1. Okay, what is the domain of this one? Okay, so whenever such questions are asked, always check. Okay, this is true for any real value, right? Any real value, this is always positive, correct? Okay. So only thing is we have to check the denominator. That is most important. Okay. Condition for the denominator, because denominator cannot be 0. If it is 0, then it will become undefined. This function will become undefined. Correct. So this should not be 0. X square minus 8x plus 12 is not equal to 0, which means x cannot be 2 or 6. Okay. So domain of this function is r minus 2 comma 6. Okay. Except this, rest all are part of the domain. Okay. All real values. Okay. This is how we have to solve the domain problems. Okay. Next. Domain and range of the real function defined by f of x equal to square root of x minus 1. Okay. Again, square root of negative number is not defined. Okay. So that is the hint for you. And so x minus 1 cannot be negative. X minus 1 should be greater than or equal to 0, which means x is greater than or equal to 1. So this is the domain here. You cannot have any other value. Okay. So domain is 1 inclusive to infinity, positive infinity. 1 to infinity, 1 inclusive basically. This is the domain. Okay. So this is all real, all positive real values including 0. This is the range. Okay. Because if you put 1 here, you will get square root of 0, which is 0, and then infinity you can get anything, right? Infinity minus 1 is always, yeah, infinity. So that's the range. So now find the domain and range of the real function defined by f of x equal to absolute x minus 1. Okay. So this is another way. So here domain is positive. X can take any value, right? Because outside you will always get only positive. So domain is r, whereas range is r plus. You get only r plus, only positive numbers you get, right? Next. Let f equal to x comma x square by 1 plus x square such that x belongs to R be a function from R to R. Okay. Determine the range of f. Okay. We need to find the range. Okay. So f of x equal to is defined as x square by 1 plus x square. Correct. So x square is always positive and x square is always less than 1 plus x square, correct? Which means the range of f is 0 to 1, correct? 0 to 1, whereas 0 is inclusive because when x equal to 0, you will get 0 value here, okay? And 1 excluding because it will never get 1, it will be always less than 1, okay? That's the range of f, okay? F of x equal to x plus 1, g of x equal to 2x minus 1, find f plus g, f minus g, and f by g. Okay, so this is simple. You have f plus g, you have to sum up both of them, which is 3x minus 2. Okay, f minus g is minus x plus 4. F by g is x plus 1 by 2x minus 1. So you have to tell the condition. Denominator cannot be 0. So x is not equal to 3 by 2. 2x minus 3 is not equal to 0 basically. Next. Okay, f equal to 1 comma 1, 2 comma 3, 0 comma minus 1, minus 1 comma 3 be a function from z to z, integer to integer, defined by f of x equal to ax plus b. For some integers a comma b, determine ab. Yeah, this is simple. F of 1 equal to, if I substitute this, if I take this equation, f of x equal to ax plus b, f of 1 equal to, if I substitute a plus b, which is equal to 1, correct? Because 1 comma 1 belongs to f, right? So f of 1 equal to 1. So a plus b equal to 1, this is my first equation. Second equation is, if I substitute f of 2, 2a plus b equal to 3. Okay, 2a plus b equal to 3. This is my second equation. So now simply I can, from these two equations, I can solve and get a and b values. Okay, so a equal to 2 and b equal to minus 1. Okay, next. R is the relation from n to n, defined by r equal to a comma b such that a comma belongs to n and a equal to b square. Okay, he's asking which the following are true or false. A comma a belongs to r, he said. Okay, a comma a belongs to r. You give a counter example if you want to prove it, if it is very easy. So 2 comma 2 does not belongs to R because it is always a comma b means a equal to b square. So if b is 2, then a should be 4. Correct? 4 comma 2 belongs to R, but 2 comma 2 never belongs. 1 comma 1 is okay, but 2 comma 2 does not belong to that relation R. Okay. So answer is no. A comma b belongs to R implies b comma a belongs to R. This is also not true because if 4 comma 2 belongs to R, 2 comma 4 belongs to R, no. So answer is no. Okay. A comma belongs to R, B comma C belongs to R implies A comma C belongs to R. Let's see, I can take the same example. 2 comma 4 belongs to R, 4 comma 16 belongs to R, but 2 comma 16 does not belong to R. So answer is no. Next. Okay. Let A equal to 1, 2, 3, 4, B is 1, 5, 9, 11, 15, 16. And F is given here. Are the following true? Okay. First question is, F is a relation from A to B. Is it a relation? Yeah, definitely there is nothing. If you see the domain 1, 2, 3, 4, and 2, and B is, yeah, some of them are used. So if you draw that graphical diagram, you can clearly see, yeah, f is the relation for sure. Okay. And f is the function, no, because 2 has two images. Okay. 2 has two images, 9 and 11. So it's not a function. Next. F is the subset of z by z. Okay. Defined as ab comma a plus b such that a comma b belongs to z. Is f a function from z to z? Justify your answer. Okay. Yeah. ab equal to x, a composite number. Okay. X can have multiple factors whose product is x. Okay, example. Okay, if I take two numbers, 2 comma, uh, if I take like say 2 into 2 by 2, okay, which is 4, correct? 2 plus 2 also 4. Okay, but 2 by 2 I can write it as 1 by 4 also, correct? So if I say 4 comma 4 is a belongs to z, then I have two ways of writing, right? 4 comma 2 plus 2 and 4 comma 1 plus 4 are part of relation by definition. Okay, since f of 4 has multiple values, okay, it has multiple values, right? 4 comma 4, 4 comma 5, two possibilities are there, correct? So f is not a function. Okay, hope you understand this. Okay, next. A equal to 9, 10, 11, 12, 13. Let A is from A to n, a function defined by highest f of n equal to the highest prime factor of n. Find the range of f. Okay, so this is simple. This is my A. Okay, set A. A is defined as f of n equal to the highest prime factor of n. What is highest prime factor n? If I take prime factor of 9, okay, 1, 3, 9 are the factors of 9, but out of that, 9 is a composite number. Okay, it's not a prime number. 3 is the prime, 1 is of course not. So 3 is the highest prime of 9. So this is what it meant to say. So 9 comma 3. Okay, prime factor of 10 is 2 comma 5. 10 is not a prime, so 5 is the highest one. Okay, it's 5 actually. You have to take prime factors of 10 are 2 comma 5, but highest factor is 5. Okay, and prime factor of 11 is 11 only. 12 it is 2 comma 3. Both are possible. Prime factor of 13 is 13. So f of 9 equal to highest prime factor of 9, which is equal to 3. Correct? 10, 5, 11, 11, 12, 3, 13, 13. Okay. So the range is 3 comma 5 comma 11 comma 13. That's it. Okay. Because there is a repetition, right? 3 and 3 is repetition. So you get only 4 elements in the range. Okay. Hope you understand this. Yeah. Let's note down some important points before getting into the JEE questions. Okay. X equal to ABC, Y equal to CBA, Z equal to 1, 2, 3. Then X comma Y are equal sets, right? Both are have same elements ABC, ABC. So X and Y are called equal sets. Whereas X and Z or Y and Z are called equivalent sets. Okay, because the number of elements are same. Okay, so equivalent sets have same number of elements. Okay, now next is functions is always subset of relations, which is always subset of Cartesian product. Note down this. Okay, next. Domain of f of x plus g of x. Okay, f of x into g of x is domain. If d1 is domain of f of x, d2 is domain of g of x, then it is intersection always. Okay, it is basically domain of these two and okay, and condition you have to apply and take the minimum set. Okay, domain of fx by gx is d1 intersection d2 minus g of x equal to 0. This condition you have to remove. Okay, this is okay. Next, if range of f of x equal to codomain of f of x, okay, then f is called onto or surjective function. Okay, just note down the terminology. That's why I'm telling. Okay, if a range of f of x is codomain of f of x, that means if you take the second set, okay, codomain set, all elements are used basically. All elements have a pre-image in uh, first set. Okay, if range of f of x is a subset of codomain of f of x, okay, if all elements of the codomain are not don't have a pre-image, then it's called into function. Okay, one-to-one function is also called injective function. Okay, if both if f of x is both surjective, that is onto, and injective into, okay, then it's called bijective function. It's called bijective function. Okay, yeah, if f of minus x equal to f of x, you call it even function. Okay, because only it is giving you only even only positive numbers. Okay, if f of minus x equal to minus f of x, it's called odd function. Okay, f of g, that fog you call it. Okay, f of g is nothing but f of g of x. Okay, just an example, if f of x equal to 2x and g of x equal to x square, okay, then f of g of x equal to g of x is nothing but x square. So f of x square, f of x square is nothing but 2x square. Okay, this is how you'll do. Okay, let's do the next. Yeah, these are all the JEE problems which we will going to solve. Very interesting problems. Let's start from easy ones first. Find the domain of f of x equal to x square minus square root of x square minus 25x plus 144. Okay, we are asking for the domain. Okay, x should be such that under the square root should be positive always. Okay, value under the square root should be positive. So x square minus 25x plus 144 is greater than or equal to 0. Okay, or equal to also should be there. Okay, so x minus 9 into x minus 16 is greater than or equal to 0. So apply Weber method, very easy. So, but anyway, minus infinity to infinity to infinity. For this Weber method, I already explained it in the sets class. So you can refer to the earlier video, the first video. Okay, 9 and 16 are the two roots. From 16 to infinity, this expression is positive. Okay, so curve starts from the top. Okay, and at 16, because power is 1, it will come down. It will change direction. Okay, and at 9, the power is again 1, so curve will change direction, go up. Okay, so now we are looking at a greater than or equal to condition, right? Greater than or equal to condition. So above ones positive. Okay, this is the range of domain of this one. Okay, domain of my expression here. Okay, so which means the domain of f of x is minus infinity to 9. Okay, inclusive. Okay, because it's greater than or equal to, as I said, and 16 to positive, 16 to positive infinity. Okay, this is my domain. Okay, so you know now how to apply. You can apply wavy curve method even for the domain, not only for the range. Okay, yeah. Next. Okay, f is defined from n to r is a function such that f of 1 equal to 1, f of 1 plus 2 of f of 2 plus dash 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 n of f of n equal to n into n plus 1 into f of n. Okay, for all n greater than 2. Okay, for n equal to 1, this is the expression. N greater than 2, this is the expression. Okay, f of n is defined as like this. Okay, what is the value of f of 2025? Okay, this is the question. Okay, yeah. So given this is given information. Okay, now add n plus 1 into n plus 1 into f of n plus 1 to the LHS side. Okay, I'm adding one next n plus 1 into f of n plus 1. Then it will be equal to, okay, already n into n plus 1. If it is up to n into f of n, this is the value, right? N into n plus 1 into f of n. So it is up to n plus 1. So it will become n plus 1 into n plus 2 into f of n plus 1. Okay, now equation 1, equation 2 minus equation 1 if I do, okay, all these terms will get cancelled. I'm left with only this. Okay, n plus 1 into f of n plus 1 equal to n plus 1 into n plus 2 f of n plus 1 minus n into n plus 1 into f of n. Okay, this side. On the RHS side, I am subtracting these two. Now, if I take the same terms, I mean similar terms to the same side, this is what I will get simplified. N into f of n equal to n plus 2 minus 1 into f of n plus 1. Okay, which is nothing but n plus 1 into f of n plus 1. N plus 1 into f of n plus 1. Okay, so which means n into f of n is equal to n plus 1 into f of n plus 1. Okay, this is what we have proved now, correct? Which means 2 f of 2 is equal to 3 f of 3 equal to 4 f of 4. Okay, up to n plus 1 f of n plus 1. Correct? So now it is very simple. So this expression will become this expression because each one is equal to the next one. All are k's. If I call this one as k, k plus k plus k plus k, all are k's basically, correct? So it will become n into k into f of n basically. Okay, so this is equal to this, which means f of 1, then f of 2 onwards, I will write n into n minus 1 f of n, okay, which is equal to n into n plus 1 f of n, correct? So if I solve for f of n, what I will get is 1 is equal to 2n f of n or f of n is equal to 1 by 2n, okay? Write the equations properly, you will understand, okay? Okay, so f of 2025 is equal to 1 by 2 into 2025, which is 1 by 4050. This is the answer. Next. A is given as 1 to 10. If a function is defined from A to A as f of k equal to k plus 1 for odd k, f of k equal to k for even k. Okay. So, the number of possible functions of g from A to A such that g of f equal to f is what? Okay. So, of f. This is what we need to find out. So, f is defined like this. You have 1 to 10 on the domain, 1 to 10 on the range. It is defined from A to A, right? And for all odd functions, it is k plus 1. So if I take 1 here, it will be 2 is the image. 2, 2 only because it is even. 3, 4, 4, 4. So this is how the function is mapped, okay, in the graphical form. Okay. Now, number of elements in domain of f is equal to 10 and number of elements in range of f equal to only 5. Correct? Only 5 are used. 2, 4, 6, 8, 10. Now, g of f, if I take g of f of k, which is equal to f of k, right? It should be f. This is what how it is defined. Okay. Now, for even numbers of k, f of k is equal to k, which means g of k equal to k. Correct? If f of for even numbers of k, f of k is equal to k, right? So it will become g of k equal to k for even number, even k. For odd values of k, okay, f of k is still even number. Okay, if it is even, it is again even. You will get same number. Correct? Correct? So odd values of g of k is not defined. Okay, because you are only uh, from this one you can only understand the even values of uh, k, right? So which means since g is from a to a, g has a fixed one-to-one relation for 2, 4, 6, 8, 10. Correct? But these values g has a fixed values which is same again. Correct? But 1, 3, 5, 7, 9 values of g, it can take any value of a. Correct? So now function has how many possibilities? G has how many possibilities? Each one of the element 1, 3, 5, 7 can take any 10 elements on the codomain. Correct? Codomain has 1 to 10. So one g of 1 can be defined as any of the 10 values. Okay. Similarly, 3 g of 3 can take any 10 values. Correct? So each element has possible 10 images in A, which means okay, for subdomain 1357 range is 1 to 10. Okay, the possible functions of G are 10 to the power of 5. Okay, total 10 to the power of 5 functions are possible. And why we are not including this one? It should be plus 1. No, this is unique anyway. It's a 1 to 1 relation. Correct? There is no change. Whatever function you take here, defined here, this is always same. 2 to 10 to even numbers, it is always same. Okay. Hope you understand this. Okay. Next. The domain of f of x equal to sine inverse of absolute x plus 5 divided by x square plus 1 is this minus infinity to minus a inclusive union a inclusive positive infinity. Then the value of a is what? Okay. So basically you need to find the domain of f of x and then just map the a value to that value. Okay. Sine inverse domain is always minus 1 to 1. Correct? It can sine inverse of 2 is not defined. Sine inverse is defined only from for minus 1 to 1. So which means this value, okay, the value here absolute x plus 5 divided by x square plus 1 is between minus 1 to 1. Correct? Inclusive, of course. Or if I take multiply this with x square plus 1, okay, multiply with x square plus 1, it will become minus x square minus 1 less than or equal to absolute x plus 5 less than or equal to x square plus 1. One good thing is this denominator will never become a 0 because x square is always positive and you have plus 1. So it will never become 0 for any value. Okay, so we don't need to add any other condition for the domain. Okay, now this is the expression which is left out. Now you can form two equations with this. You take first condition, one inequality you will get, second condition you will get another inequality. You just solve it. Okay, so first one is minus x square minus 1 less than or equal to absolute x plus 5. So I'm taking this as x square. Okay, if I take all same side basically, x square plus absolute x plus 6 is greater than or equal to 0. Okay, I will solve it for the absolute x. Okay, so this is always positive, right? This is always you will get more than for uh, because x square is positive, absolute x is positive, 6 is positive, so always you will get real numbers only here. Okay, positive real value you will get. Okay, so yeah, this is always x domain is R here. Okay, now you take the second equation. Absolute x plus 5 is less than or equal to x square plus 1, or you can rewrite it as x square minus absolute x minus 4 is greater than or equal to 0. Okay, so here absolute x is, if I apply the quadratic equation solution, I'll get 1 plus or minus square root of 17 divided by 2. Okay, out of that minus I will ignore because if I take minus, this absolute x is always positive. Correct? So 1 minus square root of 17 divided by 2 is always is a negative value. So I should not consider that. So I'm taking only this value. Absolute x is greater than or equal to 1 plus square root of 17 divided by 2, which means, okay, the domain is minus infinity to minus of this value union. Okay, this 1 plus square root of 17 divided by 2 comma positive infinity. If I compare with this, a is equal to 1 plus square root of 17 divided by 2. Okay, hope you understand. If you practice more, you can do it very fast. Range and domain problems. Okay, you have to practice more and more. Next. Okay, let a equal to 2, 3, 6, 7 and b equal to 4, 6, 4, 5, 6, 8. Okay, R is a relation defined by a cross b by a1 comma b1 relation to a2 comma b2 if and only if a1 plus a2 is equal to b1 plus b2. Okay, the relation is defined in this Cartesian product such that if you take any two ordered pairs, okay, the first sum of first elements is equal to sum of second elements. Okay. Then the number of elements in the relation R. Okay. How many number of elements are there in this relation? Okay. So what we need to find out is basically, okay, we need to first find the number of elements in the relation. Okay. We need to determine all pairs such that A1 plus A2 is equal to B1 plus B2. Okay. Where A1 comma A2 belongs to A and B1 comma B2 belongs to B. Right. So first let's consider all possible sums within the set A within the set B. Okay. So if you write sums from set A, 2 plus 2, this is possible, right? Correct? 2 plus 2 is 4 because 2 and 2 can become two ordered pairs here. A1 can become 2, A2 can become 2, B1, B2 come from the B. So let's see. 2 plus 2, 4, 2 plus 3, 5. So I am writing all 4 into 4, that is 16 possibilities here and 16 possibilities in the B. Now, if you clearly look at, only few values are same actually. Sum of two elements is same for only few values. That is 8, 9, if you take, correct? 8 is both sides, 9 is both sides, 10 is both sides. So these elements are possible in this relation R. R can have these values where repetition, where both sides the equality is there. Okay, sum of two elements equality is there. So how do we do it now? 8, if I take sum, options from set A, there are two options, right? 8 and 8. Okay. Options from set B, only one. So number of pairs in relation R, okay, is 2 times 1. Correct? 2 into 1. This 2 can form only to the only can be mapped only to this 1 from set B. So 2 into 1, which is 2. For 9, there are 4 possibilities in set A and 2 possibilities in set B. Okay. So 4 into 2, 8 pairs are possible in the relation. So similarly, you do it for 10, 12, 13, 14. Then the total number of pairs in relation is 25. Sum of all this. Okay, 25. Okay, this is a very interesting problem from JEE mains. Okay. Next. A is 1 to 20. Let R1 and R2 are two relations on A such that R1 equal to A comma B and B is divisible by A. R2 is A comma B such that A is an integral multiple of B. The number of elements in R1 minus R2 is equal to. Okay, so first form R1 and R2. Let's see how many values will come. Okay, R1 is where A B is divisible by A. Correct? So if A is these values, A is 1, B can be 1 to 20, any of these 20, correct? All 20 are possible because all 20 are divisible by 1, right? So 20 ordered pairs will be there, okay? When A equal to 2, you have only even numbers basically 2, 4, 6 up to 20, so 10 possibilities are there. B can be uh, any of these 10 values. If it is 3, you have 6 values, 3, 6, 9 up to 18. 4, you have 5. So similarly, you write for all. After 11, you will get only one value for each. 11, 12, 13, 14 up to 20, you will have only one. Same numbers basically. 11, comma 11, 12, comma 12, 13, comma 13, like that. So there are total 10. Total ordered pairs are 66. 66 order pairs are there. Okay. Now, are we looking at this one? We need to find out R2 also. R2 is exactly, what is the definition of R2? A comma B such that A is the integral multiple of B. Okay, which means if it is exactly reverse of this, right? Okay, so if A comma B belongs to R1, then B comma A belongs to R2. Okay, so exactly reverse of this one. So if number of elements in R2 equal to number of elements in R1, which is 66. Okay, so only thing is we are looking at R1 minus R2, so we have to remove all the common elements. Okay, how many common elements are there? 1 comma 1, 2 comma 2, 3 comma 3, you will get up to 20 comma 20. 20 common elements is what you will get. Okay, so if you remove all these things, R1 minus R2 is, okay, R1 minus R2 is nothing but number of elements in, no, sorry, R1 intersection R2 is 20. So R1 minus R2 is nothing but this is number of elements. N of R1 minus R2 equal to number of elements in R1 minus number of elements in R1 intersection R2, which is 46 is the answer. Okay. Next. Yeah, that's all. So these are the problems, type of problems which comes from JEE mains and other entrance exams. So with this actually sets, relations and functions is the chapter we have studied, learned the basics and solved the problems. I will do more videos and shorts based on these problems uh, which are very typical in all the competitive exams. I will choose them and which are good to solve And for practice, all those things I will keep adding. So keep checking my videos. Thank you.